60 Newton. Example 4. A motor car moves around a circular track of radius 0.3 meter at 2 revolutions per second. What is A, the angular velocity, phi, B, the period, capital T, C, the speed v of the car, D, the angular velocity of the car as it moves with a uniform speed of 2 meters per second in a circle of radius 0.4 meters. Looking at the diagram, we are told that the vehicle is moving around a circle of radius of 0.3 meters and that the speed of the vehicle is 2 revolutions per second. Solution. We are looking for the angular velocity, which is unknown. Phi is now equal to theta over t, which is equal to 4 pi over 1. 1 revolution is equal to 2 pi radians. 2 revolution is equal to 2 pi times 2, which will now give us 4 pi radians per second. Phi is now equals to 12.6. If we substitute the figures into the unknown values. B, we are now told that we are looking for the period t, which is equal to 2 pi over 4 pi, will now give us 0.5 seconds because of period is equal to 2 pi over 5. Then, if you substitute the values, if we are looking for the velocity, and then we substitute the figures into the unknown values, we now have that v is equal to radius times 5, which is now 0.3 times 12.6. V is equals to 3.78. Phi is still unknown. The v, which is the velocity, is given to be 2 meters per second. R is the radius, which is 0.3 meters. B is equal to radius times phi, which is angular velocity. Therefore, making the phi the subject of the formula, we now have v over r, which goes to phi. We now have 2 over 0.4, which gives us 5 radians per second. Example 5. A pendulum bulb of mass 1 kilogram is attached to a string of 1 meter long, meant to revolve in a horizontal circle of radius 0.6 meters. Find the tension in the string and the period of the motion. Take G equals to 9.8 meters per second squared. From the diagram, you can see that the pendulum bulb of 1 kilogram is hung by a string of 1 meter going through a path of a radius of 0.6 on a circular path. Resolving the forces on the body, the bulb moving on a vertical force will be equal to T sin theta, and the body being drawn on the horizontal force will be T sin theta. See, the ball is still at 1 meter with the string at a radius of 0.6 of an unknown angle, and the weight of the ball is mg. Solution. The horizontal components provides the centripetal force. T cos theta is equals to mv squared over r. Vc is equal to mg because the body is in equal velocity. T sin theta is now equal to mg. According to Pythagoras theory, the square root of the hypotenuse is equal to the square root of the other two sides. Then we have that h squared is equal to 1 squared minus 0.6 squared, which will now give us 1 minus 0.36. H squared is equal to 0.64. H will now give us square root of 0.64, which gives us 0.8. Sin theta is equal to 0.8. Tan sin theta is equal to mg. Theta is equal to 0.8 is equal to 1 times 9.8. Theta is now equal to 9.8 over 0.8, which gives us 12.25 Newton. Tension now become 2 pi over 5. For V equals to radius times 5, T cos theta is equal to mv squared over r. 12.25 times 0.6 is equal to 1 times v squared over 0.6. 12.25 is gotten by timesing the t we have gotten with the cos of tan, which we now have as 12.25 times 0.6, which equals to 1 times v squared over 0.6. 12.25 times 0.6 times 0.6 is now going to give us v squared. V squared is equal to 4.41, which now gives us 2.1 meters per second. V is equal to radius times angular speed. Substituting the figures into the unknown values, we have that V 2.1 is equal to 0.6 of the radius times 5, which is the angular velocity unknown. Making angular velocity the subject of the formula, we have that 2.1 over 0.6. The angular velocity will now give us 3.5 radians per second. T is equal to 2 radians over 5, which gives us 2 pi over 3.5, which gives us 1.8 seconds. Example 6. An object of mass 8 kg is weighed round a vertical circle of radius 2 meters with a constant speed of 6 meters per second. Calculate the maximum and minimum tension in the string, given acceleration due to gravity g is equal to 10 meters per second squared. When a body is weighed in a circular path, the minimum force tension will be acting on the top, while the maximum tension will be acting below the circle. Solution. Maximum tension is equal to mv squared over r plus mg. Maximum tension, by substituting the values of the unknown figure, we have 8 times 6 raised to power 2 over 2 plus 8 times 10, which will now give us 144 plus 8, which will give us 224 Newton. Minimum tension is equal to mv squared over r minus mg. 144 minus 8 will give us 64 Newton. Example 7. Calculate the force necessary to keep a mass of 0.2 kg moving in a horizontal circle of radius 0.5 meters with a period of 0.5 seconds. Solution. Centripetal force F is equal to mv squared over r, or m r phi. The period t is equal to 2 pi over phi angular velocity, which is equal to angular velocity times period t, which is equal to 2 pi. Phi angular speed is equal to 2 pi over t, which will give us 2 pi over 0.5 when you substitute the figure into the unknown value. You now